Today in class 10th we will learn simple machine. So what is a simple machine? A simple machine or machine is a device that help us to overcome a load with less effort or force. Learn what is a simple machine? A machine is a device that help us to overcome a load with a less effort or force. Effort is also known as the force applied by us. So in simple machine we have to study lever, pulley and inclined plane only. These all are simple machine, but we have to learn only lever, pulley, inclined plane and also the pulley. Lever, pulley and inclined plane you have to study. Let's see what is lever. A lever is an example of a simple machine which turns about a fixed point called fulcrum. This is a rod known as a lever. This is called fulcrum and this is called load, and the force applied by the person, that is called effort. When a force called effort E is applied to overcome a resistance force called the load. Using a lever to overcome a large load with a small effort means we have to apply less force to lift this heavy load. This is called lever. Now in lever we have to see three terms: load, effort and fulcrum. This is called fulcrum, this is called load and this is called effort. Fulcrum, load, effort. Learn it. Fulcrum is represented by F, load is represented by L and effort is E. Load is the weight to be lifted up, effort that is the force applied by the person. Then class of lever. We have three class of lever. Number one, first class of lever. So how to recognize that the given machine or lever is a first class, second class or third class? It totally depends the term which is at the middle. If the fulcrum is between load and effort, then it is first class of lever. So what is first class of lever? A lever which has the fulcrum between the effort and load, known as first class of lever. These are the example of first class of lever: hammer, plier, that is called lid opener or bottle opener, and this is scissor and shears. Then second class of lever. In second class of lever, load lie between fulcrum and effort. So what are the example? Let's see: bottle opener, wheelbarrow, nut cracker and paper cutter. These are the example of second class of lever. Now third class of lever. If effort lie between fulcrum and load, then it is third class of lever. Let's see the example: broom, tongs, arms and stepper. Arms means when you lift something like this, that is called, it is a means example of third class of lever, and stapler. Now the important term in machine or simple machine you may say, that is a mechanical advantage. What is mechanical advantage? So mechanical advantage is actual, this is the formula given. Let's see first of all the term given. MA stands for mechanical advantage. FR, that is called resistance, force or load, it is load. And what is FE? That is called effort. So mechanical advantage is the ratio of load upon effort. So mechanical advantage is the ratio of load upon effort. This is called actual mechanical advantage. Second example, that is second formula of mechanical advantage. The DE, what is? That is distance of effort from the fulcrum, and DR, that is the distance of resistance or distance of load. So the ideal mechanical advantage is calculated with the help of this formula. Ideal mechanical advantage, effort R upon load R. Now velocity ratio. This is another term, velocity ratio. What is the velocity ratio? The distance traveled by effort to the distance traveled by load is known as velocity ratio. The velocity ratio, distance traveled by a distance moved by effort to the distance moved by load. The person applying effort, so the distance traveled by effort, that is 300 mm, and the distance traveled by load, that is 100 mm. So that is 300 upon 100, that is 3:1. This is the definition of velocity ratio. Now the third, efficiency. You have to learn the efficiency. What is actually efficiency? Efficiency is the ratio of work output to work input. Now you have to obtain a relation between efficiency, velocity ratio and mechanical advantage. You know very well velocity ratio is distance traveled by effort to the distance traveled by load, and efficiency is work output upon work input. So efficiency, work output, that is load into load, distance traveled by load, and work input, effort. Input means we give the work, output the work which is obtained from the load. So load into distance traveled by load upon effort into distance traveled by effort. Load upon effort, that is called mechanical advantage, and we know very well distance of effort upon distance of load, that is called velocity ratio, but it is the reciprocal. So distance of load upon distance of effort, that will be 1 upon velocity ratio. So efficiency is equal to mechanical advantage upon velocity ratio. You have to prepare these all things and write a copy. Now see how the three types of lever are being in human body. Simple machine in the body. Learn it because in paper they may ask. Nodding of head, that is called first class of lever. This is fulcrum, this is input force, this is load. So nodding of head, that is called first class of lever. Raising your weight of the body on your toes, that is called second class of lever. How? This is called fulcrum. This is actually the effort and this is load. The load of the body acts between at the mid, and the effort is applied by this calves. Then third class of lever means lifting a body by your arm. So that is called third class of lever. That is actual. Now these are the three types of lever in human body which you have to learn in your mind.